let us understand join operations. Streams can be very easily joined with other streams. Here, in each batch interval, the RDD generated by stream 1 will be joined with the RDD generated by stream 2. We can also do left outer join, right outer join, and full outer join. We can also join windows of streams as displayed in the code. We have already seen join of dStream and dataset in transformation operation. As shown in the code, we can also join a windowed stream with a dataset. Read more about join operations using link displayed on the screen. Output operations allow dStream's data to be pushed to external systems like a database or a file system. Since the output operations allow the transformed data to be pushed to external systems, they trigger the actual execution of all of the dStream transformations. This is similar to actions on RDD. Let us discuss the available output operations on dStreams. Print operator prints the first 10 elements of each batch of data in dStream. Please note that it prints on the driver node running the streaming application. This is useful during development and debugging. Save as text files operator saves the dStream's contents as text file. The file name at each batch interval is generated based on prefix and suffix. Save as object files operator saves the dStream's contents as sequence files of serialized Java objects. The file name at each batch interval is generated based on the prefix and suffix. Save as Hadoop files operator saves the dStream's contents as Hadoop files. The file name at each batch interval is generated based on prefix and suffix. For each RDD is the most generic output operator that applies a function func to each RDD in the stream. This function func pushes the data in each RDD to an external system, such as files or writing it over to the network inside a database. Note that the function func is executed in the driver node running the streaming application. Let us discuss the design patterns of for each RDD operator. As we have discussed that it allows data to be sent out to external systems. Sending data to external system requires creating a connection object such as TCP connection to a remote server. Data is sent to the remote server using TCP connections. As a common mistake, a developer may try creating connection object at the Spark driver and then try to use it in a Spark worker to push the data in RDD to a remote system. This is incorrect. As you can see in the code, this requires the connection object to be serialized and sent from the driver to the worker. Such connection objects are rarely transferable across machines and would give serialization error. The correct solution is to create the connection object at the worker. As you can see in the code, we create a connection object at the worker. However, this can lead to another common mistake, that is, creating a connection for every record. Creating a connection object has time and resource overhead. Creating and destroying a connection object for each record incurs unnecessary overheads. This can significantly reduce the overall throughput of the system. A better solution is to use rdd.forEachPartition. It creates a single connection object and sends all the records in an RDD partition using that connection. As you can see in the code that it creates connection object just once for all the records in an RDD partition. This reduces the overhead for creating a connection object for many records. We can further optimize this design by reusing connection objects across multiple RDDs and batches. As you can see in the code that we are reusing the connection from the connection pool. Read more about output operations on dstream using the link displayed on the screen.